A logic circuit is the building block of all modern digital devices, including computers, smartphones, and the internet. Now, most people are familiar with a computer and have heard about a computer processing information as ones and zeros. And this is true. A computer is considered a digital device. Now, digital means that we look at information as only a 1 and a 0, and we aren't concerned necessarily with how that 1 and 0 is represented. Now, of course, a 1 and a 0 is represented with electrical quantities such as voltage and current, but if we are a logic or a digital circuit, we don't care about how the 1 and 0 is represented. We just care about its logic value. Either it's a 1 or a 0, and the circuits we produce are also a 1 and a 0. Now, a computer consists of hardware and software, but in this course we are only going to focus on the hardware component. Programming a computer is a different class. We will be looking at the logic circuits, the building blocks of all the digital hardware that we use in our society today. And like I say, this can include smartphones, game controllers, tablets, etc. Now, in this course, what we are going to do is we're going to start at the beginning. This is an introductory course, so we are going to start with what a 1 and a 0 is, how we're actually going to represent information using ones and zeros, and then we're going to build our way up to understanding how you actually build circuits out of it. So we're going to look at basic logic circuits. We're going to look at how to put those logic circuits together to form more complex circuits, and then we're going to get into circuits that can actually store information such as ones and zeros and use that storage to make even more complex decisions about what to do next. So before we get started on the learning activities for the course, I thought I'd give you a little background on myself, since I'll be the voice that you hear in the videos and also the author of the textbook that we'll be using. So like I say, my name is Brock Lemires. You can call me Brock. I'm a professor at Montana State University, and I'm in the Electrical and Computer Engineering department. My focus is primarily in the area of computer engineering or digital hardware. I got my bachelor's from Montana State University back in '98, and then I went to work for Hewlett Packard in Colorado Springs. And there what I did was I was a hardware design engineer where I focused on digital system design. And I worked there for 8 years, and while I did that, I got my master's and PhD from the University of Colorado. And then I joined Montana State 12 years ago in 2006. And since then, what I've done is I have taught courses in digital systems, ranging from introductory level all the way up to graduate level advanced digital systems classes. And I've conducted research in the area of computer engineering, primarily for NASA, so looking at new types of architectures in order to create optimal systems for their various missions. So if you're interested in learning anything more about kind of my research, you can come out to my website, and I have a bunch of links to various news pieces about the research that I've done, courses that I've taught, and educational activities that I'm involved with. So that's me.
Now let's look at the course logistics and how to get started on the learning activities for this course. So the first thing you want to do is log into our course management system, and that's found at ecat.montana.edu. And you're going to come to a login which is called Brightspace, which is it's the tool that we use, the course management tool, but it's by a company called Desire to Learn. So you'll kind of hear me use the terms Brightspace or Desire to Learn or D2L interchangeably, but it just refers to the website that you log into to do the course. So you're going to want to log in with your MSU NetID that was assigned to you and also your password. And when you do that, you're going to come to your kind of your main screen of your login, and you'll see down here on the lower right that you're going to see all your active courses. So you will see a course which is called 591 Logic Circuits for Teachers. And when you click on that, you're going to be brought to that course website. So the first thing you're going to see here is you'll see an announcement, which is just, I just put this here as kind of a welcome screen so that you know you got into the right course. And there's really nothing here. What I do with this course is I put everything within the content area of Desire to Learn. So if you come down here, you'll see, what are you going to do now? Click here. If you're watching this video, you probably have already done this. And so it's going to bring you to the course information and syllabus page. So here you're going to find the most up-to-date contact information for myself. Email is my preferred mode of communication, lemires@montana.edu. We also have a teaching assistant for our summer course. His name is Trevor, and you can email him at this link right here. And so if you email one of us or both of us, we'll try to reply to you at a minimum within 24 hours, okay? And on this page, this is going to mirror the stuff that's on the syllabus. I put this here mainly for contact information, but it's also got some of the highlights of the materials that you need. So let's start with looking at the course syllabus. So if you click on the course syllabus link, you're going to be brought to this 7-page document. And this is going to give you kind of the overview of the course, grading, and the schedule. So we already kind of covered what this course is going to be about. You're going to have a variety of learning objectives and outcomes that are kind of summarized right here. Then you have the contact information again. This course runs from June 11th to August 3rd. It's a fully online course, so you can do this anywhere in the country. But what you'll need to do this are 4 things. So the first thing you need is a computer with high-speed internet running Windows. The reason you have to use Windows is because we're going to be using some design software for homework and some of our labs that does not run on a Mac. So if you have a Mac, you can't do those assignments. Now, if you have a Mac and you have access to a Windows machine, that's probably okay as long as you can install software on the Windows machine. A lot of teachers will use their Macs for the majority of course, and then they'll maybe just run over to their school and use a Windows machine to do the few homeworks and labs that run Windows. Or if you can also remote in. So the big thing is that if you don't have access to a Windows machine, you're not going to be able to do some of the assignments. So if you want to continue in the course, just give me, email me and let me know your situation, and we'll try to figure something out. Next thing is you're going to need the textbook. So the information's right here, Introduction to Logic Circuits and Logic Design with VHDL by me. The cheapest version of this book is on Amazon, so it's usually somewhere less than $60. The next thing you need is a portable lab kit. And each of you has received a shipment from me at this point. And inside of that, you're going to have all the materials that you'll need to actually build some logic circuits, power the circuits, take measurements on the circuits, and do basically all the lab activities for the course. And then in order to show that you've done some of the lab activities, you're going to basically do screenshots of measurements, and then you're going to also take short videos. So you need some sort of camera capable of taking short videos. Everybody who does this course just uses a smartphone, so you got to make sure that you know how to take a 3 to 5 second video and then get that file and upload it to the Desire to Learn shell. Okay, prerequisites is the really only requisite for this course is a course in algebra. So this is not a calculus-based course. Course website, we just covered that. In terms of office hours, there's really no set office hours. Just email me or Trevor anytime and we'll get back to you right away. The way that grading is going to work is there's 2 graded items in this course. There's going to be homework and there's going to be labs. So the reality is all the learning takes place in the labs because that's where you actually get hands-on experience. So you'll notice that about 65% of the course grade is based on the labs, 35% is the homework. And so when we go look at the lab or the grade breakdown, you'll notice that there's a total of 700 points available. So you can kind of keep that in mind to see how you're progressing through the course. Grading scale is just a flat 90, 80, 70 in terms of ABC. I usually don't get pluses or minuses. If there's special situations at the end of the course, we can talk about it. Academic policies, I mean, the expectation is that you do your work on your own, but if you are collaborating with another classmate, that's fine too. Just make sure that you guys are each doing your own work and upload your own files. And even if you work together on a lab, it's fine. Just make sure that you each upload files to your own folders in the Brightspace thing. Okay, now we get to the course components. What are you actually going to do in this course? It's really 4 things. So you are going to be assigned reading assignments. Then you're going to watch instructional videos. The instructional videos are like identical to the reading. It just gives you a different mode. Some of the instructional videos will have more examples, but the reading is directly out of this textbook. So the textbook was written for this course. So the course existed. We developed this over the last decade to get it where we wanted. Then I wrote the textbook. So what you'll notice is that we cover this textbook from page 1 up to page, like 300, and we cover chapters 1 through 7. So if you really want to see what this course is about, you just go from section 1.1 in chapter 1 all the way to the end of chapter 7. We're going to go through every single section in the textbook in order, and the homework is directly out of the textbook. The videos are, many times I'm just talking over the textbook. So the reading and the instruction videos are very similar to each other. And sometimes people don't need to watch the videos. They learn better by reading, and vice versa. So whatever works for you. Some people, need both or want both, and so they're both resources for you. But that's the way that you're going to get the information into your brains. And then homework is going to allow you to start, interacting with the material. Okay. The homeworks come in two formats. One is just your standard multiple choice online quiz, which is administered within the Desire to Learn system. But then there's going to be other ones later on in the class where you'll actually run a simulation of a logic circuit. And that's going to use that software that I mentioned before that only runs on Windows. And for the simulations, you'll be doing screenshots of your outputs, and you'll upload the source code to a folder, and then we'll be able to grade it from there. And then you're going to do the laboratories, or the laboratory assignments. And again, you'll do, a couple sections with homework, and then all of a sudden after a few sections build up to a point where you can build a circuit, you'll do a laboratory, and you'll demo that with screenshots. Okay, let's look at the schedule. So I've broken down the schedule into a monthly view and then also as a grading view. So I laid this course out as if we were going to meet Monday and Thursdays, okay? And so what I have is for the 8 weeks, you'll see that I have assignments for each of 2 days per week. And then the way that the deadlines work is that the Monday activities are always due on Wednesday at noon, and then the Thursday activities are always due the following Monday at noon. So you don't have to necessarily do these exactly on Monday. It does give you some flexibility. You just got to make sure that all of the material that is assigned right here is due or is turned in by Wednesday at noon. And all the material that is assigned here is turned in by the following Monday at noon. And that is consistent throughout the entire 8-week summer session. Okay. So you'll get into a pattern, and hopefully these deadlines won't sneak up on you because they're always going to be the same. When you look at this, when I list out these things like homework 1.1, homework 1.2, lab 1.1, these are all graded assignments. So when you look at this thing, these are going to be 3 different graded items that you'll have to do and submit before Wednesday at noon. When you come over here, you'll notice you have 4 homeworks and 1 lab that are due the following Monday. What you'll notice is that not all homeworks, not all chapters are equal in difficulty. So sometimes you'll have more homeworks, sometimes you'll have less. I tried to balance it out so that the effort level, both in time and difficulty, is about the same. For example, when you get into week 2, you'll notice you have 3 homework assignments, but then you only have 1 lab on the Thursday course that's due the following. So this lab is a little bit more involved than, let's say, lab 1.1. And so that's the only thing you're going to do. I reflect also the difficulty of the assignments in the points that they're worth. So you'll notice that lab 3.1 is going to be worth a lot more points than 1.1. And we'll look at that in a second. And so we just basically start going through each and every one of these. And the homeworks, homework 3.1, that represents a section in the textbook. So you got a section 3.1, you're going to read, watch some videos, and then do the homework. And I marked the ones that are the simulation versions. So you'll see that if it has an asterisk, you're going to actually use the software instead of doing a multiple choice quiz or a multiple choice format assignment. Okay, so this goes on. During the final week, just so that you can, if you want to kind of see how you did in the course, I have a final exam that's ungraded and totally optional. It's basically like a 2-hour online multiple choice format comprehensive exam. And a lot of people take it just to kind of see how they learn the material in the course. But it's optional. But when you look at the schedule, you notice this red thing right here. So there is no graded final exam. It is an optional thing. Okay, so that's the 8 weeks. Another view of the activities is in this activity flow table that I give you in the syllabus. And this is where I tell you how many points every assignment is worth and when that assignment is due. So I break it into homework and labs. And so you'll notice that as you walk through this sequence, if you just do this course, you are just going to walk through this table in order and do each of these learning activities. Each one of these activities is going to involve a reading assignment, instructional videos, and then some sort of graded homework. Notice that you do a couple homeworks, then you do a lab. And then you'll do some homeworks, then you'll do a lab. And then you'll do 4 homeworks, then you'll do a lab. Sometimes you do 3 homeworks, then a lab. And so that's just the flow. So this is going to walk you through each and every one of these graded assignments. And as you get down to the bottom, you'll see that the homework totals up to 250 points. The labs are worth 450 points. That's 700 points. So you can kind of see the level of difficulty of each one of these, lab assignments. They're not all weighted equally. Same thing with the homework assignments. Okay, and then finally, the last 2 pages of the syllabus show you very specific learning outcomes for each section that we're going to cover in this textbook. And this, when you look at these, it's always good to look at these before you start a section just to have an idea of what we're trying to learn. But once you get done with the course, what's interesting about this, especially for teachers, is you can go back and you can kind of look at these and go, okay, these are specific things that I learned. These might be something that I wanted to create a learning module in my own class. So maybe something like number systems, you want to show your students how to convert between different bases. So you want to convert between decimal and binary. And you come in here and you go, where did I learn that? Oh, it was section 2.2. You open the textbook, you go into the textbook and you review that material and you can create your own learning module. I also give you the Bloom's taxonomy breakdown of the level of learning. So you start with knowledge, which is kind of just facts and figures, all the way up to synthesis, which is actually designing something. So each learning module or each learning outcome is not the same. Some are just knowledge, but some are, more heavily, more higher level thinking, such as application and synthesis. So I have all the learning outcomes for each section in the book that we will be covering. Okay, so that's the syllabus. Now let's take a look at how you actually get started. So in this course, you're going to notice that there's all these different tools you can click on. All you ever need to do is click on content. So in content, I have a page for each module that we're going to cover. I call it module. It corresponds to a chapter in the book, but it's more than just a chapter because you have the instructional videos and the assignments. So you look at this page we were just on, it was a course information and syllabus. Well, if you go to module 1, this is the activities that you'll be doing for learning content on analog versus digital. So you'll come in here and you'll notice that I first list out the learning outcomes, then I give you the activities. So here's section 1.1 in the book. It's going to be read section 1.1, watch this video. When you click on that, a YouTube video will start. So I'll click on it. So here's the video, and
in this video, we're going to look at the differences between analog and digital systems.
And so that's me sitting there talking, and you'll notice that I'm doing all sorts of things. I'm writing on paper. Sometimes it's PowerPoint. Sometimes I'm actually building circuits. Sometimes I'm writing code. So these videos, you should be able to follow along. They match the textbook almost identical. And so that's a different mode of learning. So then when you get down here, you're going to get to the graded deliverable. So for section 1.1, you're going to say do homework 1.1. When you click on that, they're always in the form of a multiple choice quiz unless you're told different. Now, the way that homework works is the homeworks are all open. They're just due at a certain time. So after the due date, they go away. But one of the things about the homeworks is that you can open them, work on them, save, and then come back. You just got to make sure that you remember to submit it before the deadline. So when you come in here, you're going to see something that looks like this. Homework 1.1. Over here, you're going to see the pages. Make sure that you take note of pages. So not all the times are the questions listed on one page. Sometimes you have a whole bunch of pages. So you can kind of see the layout here. If you ever try to submit a quiz without answering a question, it'll flag it. But you can just see, it's like, what part of a system will always require an analog component? Well, it's the interface between electrical components. Or excuse me, any electrical component that must interact with the physical world. It's like, okay. And so you go down here, click through. And then you can save it and come back later, or you can submit. And when you submit, it will grade it, tell you your grade, and you'll be able to go back and look at what you missed if you did miss anything. And your grade will immediately go into the grade book, okay? So if you go back to content and kind of look at the flow for module 1, you'll notice that we did, okay, section 1.1, section 1.2 was read, watch a video, homework. Then there's a lab activity. And so here's the lab. You got this portable lab kit in front of you. How do you get started with the lab? Well, here's what I've done. If you click on the lab description, each one of these lab assignments is in this giant PDF that I've created. The PDF has all the lab assignments in it, so you only need to download it once, even though I have that link spread throughout anytime you'll need it. So if I come along and I scroll through this thing, the first thing you're going to see is the part list. So these are all the parts that you have in your parts kit. And I have links to the data sheets right here. So if you're wondering, like, what are the pins on here? What are the inputs or outputs, power? You go into the data sheet and it'll link you and it'll tell you exactly what that what that particular part does. Okay, so if I click on that link, it takes me to this Texas Instrument, and it tells me all the stuff that I needed to do. If you've never read a data sheet, that's not a big deal because we actually have a whole section on data sheets, how to read data sheets. That's one of the big things with this class is I'm assuming it's the first time you've ever seen any of these little parts, and you're going to put them on this wiring board, wire them up, you're going to supply power, and lights are going to blink. And so it's okay if you've never seen any of these components. That's the whole purpose of this course. Okay, so you come down here, and here's analog, here's lab 1.1. Again, some learning objectives, parts needed, and then the deliverables. So notice immediately in this lab, you're going to demonstrate the use of this thing called an AWG that you'll learn about to make an LED blink, and then you're going to take a measurement. So how do you create those deliverables? As you walk through this, the labs are really written up as a tutorial. So it's like you just walk through, read through everything. It shows you exactly what you're going to be doing. It leads you through everything. When it comes time to create a deliverable, what I do is I highlight it in red and I tell you what you're going to do. So for deliverable 1 for this lab, you're actually going to take a video of this particular circuit. Okay. And then when you come down here and you look at deliverable 2, I tell you to take a screenshot of a measurement. All right. So that's how you're going to be doing these labs. And all you do to turn them in is you upload it to this assignment folder. So when you click on here, it's going to take you to a part of Desire to Learn or Brightspace where you can upload files. Now the overview video is again very similar to the lab description, but it shows me doing the lab. So sometimes people like this a little bit more because
in this video,
it shows me doing it. So if you look at this, I mean, I'm wiring things up. I'm doing the lab right with you. I'm showing you how to install the software and everything. So you should be able to walk through or have the video playing, and then you got the stuff in front of you and you're off and running. Okay. Okay. So that's how you do it. And that is the process you will do for each and every module. So if I come over here and click to the next module, if I come over to this arrow, it'll take me to module 2. I could also go to content. Here's module 2. Look at what you do. Section 2.1, you read, you watch a video, do a homework problem. Section 2.2, you're going to read, you're going to watch 3 different videos. I tried to break them up to be a little bit smaller and to be more topical. Then you're going to do a homework. Section 2.3, read, watch a video, do the homework. 2.4, read, watch some videos, do the homework. Then you do a lab. Okay. So in this situation, it gets very repetitive, and you'll get the hang of this right away, and you'll get the flow of what we're doing. Now, if you want to see your grades and what they're doing, or as they pop in, you can click on the grade thing and you'll see each and every one of those graded items over here, and you'll see the points that they're worth. And then when you look at this view, this is the instructor view, you'll actually see your score over here, and then you'll see little lines that actually show that you haven't attempted it yet. Okay. All right. So in terms of any other tools, assignments is just where the folders are. Again, everything up here is linked to the content page. So I never even really mess around with any of these other things. I just always go to the content page so I know where I'm at. And that way I have links to everything. So if it's a YouTube video, it's linked here. If it's a quiz tool, it's linked here. If it's a PDF, it's linked here. If it's a folder, an assignment folder, it's linked there. That's it. The only other thing you might want to see is a view of the calendar, just kind of see when things are due. And this will show you kind of the calendar, and it highlights when things are due. But in reality, what I would rather do is I always look at the syllabus. So every time that you are thinking about, okay, it's time for me to do my activities for Monday, I always come back to the syllabus and say, okay, look, I should be doing 2 homeworks and a lab, and they're going to be due Wednesday. And it's like, okay, I know exactly what I need to do for this time period when it's due. And if I was curious about the points that it's worth, I would scroll down here and go, there it is. Okay, so that is the course. So like I say, email is the preferred way to get a hold of me. So you're going to want to, don't hesitate on any of this stuff. So you have a live teacher and you have a live teaching assistant when we're here, all the time. So if you get stuck on something, don't stay stuck for long. You don't want to spend a whole lot of time just beating your head against the desk. It's like email me or email Trevor, and we'll try to get you unstuck. Things that need to be graded by us, like the labs, they will be graded shortly after the deadline. Okay, that is it. Well, good luck, and I look forward to working with you this summer.